All right, so let's say we had two consumption bundles, both on the same indifference curve. So one consumption bundle is 1 beer, 8 samosas. The second consumption bundle is 5 beers, 4 samosas. If I asked you to plot the indifference curve, okay, and we're gonna, let's say we'll put beer on the x-axis, and there's no way in hell I'm writing samosas out, so you're just gonna get an S over there. So you're gonna plot the indifference curve. So, we're gonna make the assumption that diminishing marginal utility applies, so therefore you prefer average bundles. You'd prefer somewhere in between, you prefer 3 beers and 6 samosas to either of these two consumption bundles. So it's going to have that curved out shape. Oops, sorry. So yeah, all right, whatever. This is. So these two are going to be on the same line. So let's say 1 beer, 8 samosas should be like somewhere up here, and 5 beers, 4 samosas should be like somewhere over here. Okay. Boom. Okay, let's say this utility is equal to x. And like I said, there might be like a third point somewhere between here. So let's say it's like 3, 6. Well, we'd expect that to be on a higher indifference curve, right? So if we went to 6 samosas, you'd be like down here, but 3 would be over here. We'd expect that to be on a higher indifference curve. Your utility is greater than x. Okay. But that was just to explain the shape of the curve. But let's stick with just the one curve for now. Okay. So if I'm at, let's call this point A. Let me erase this here. If I'm at A, okay, and you asked me at point A, how many samosas, or let's say how many beers, no, let's stick to samosas. How many samosas I'm willing to give up for 1 beer What do you think? Would it be a lot of samosas, a little bit of samosas? Well, I would think, so you're only consuming 1 beer and you're consuming 8 samosas. So you're consuming an extreme amount of samosas relative to beer. So I would think you're willing to give up more samosas in general in order to get that 1 beer. That 1 beer is going to have a high marginal utility. The extra samosas, or the samosas you're giving up, like the 6th or 7th samosa, are going to have a low marginal utility, right? So if we were to graph their marginal or their utility, so beers utility, samosas utility, right? You're at the 8th samosa, so you're probably closer to this point, whereas your beer is only at 1. So you're probably closer to like this point here. So this point still has a high marginal utility. So you still have a high margin utility going from 1 beer to 2 beers. Okay. But you have a low margin utility going from 8 samosas, or let's say 7 samosas to 8 samosas. So if you want to increase your marginal utility, you'd rather trade that you'd rather trade the 8th samosa for a beer. If you want to get the most utility, you should trade the 8th samosa for 1 beer. At least. You might be willing to trade more than 1 samosa for 1 beer. Okay? So basically, if you're using marginal analysis or using marginal utility as your deciding factor, which you should, that's the rational way to think about this, you want to consume some mixture between beers and samosas. At point A, you're consuming an extreme amount of samosas, very few beers. So the additional beers you consume are going to give you a high utility, aka you're going to get a high marginal utility going from that first beer to the second beer. But if you trade for a samosa, you're only losing a little bit of utility from the samosa that you give up, because you're already, at this point, you're already at like a very low marginal utility state when you're consuming, going from 7 samosas to 8 samosas. The 8th samosa has a very low marginal utility. Okay? So you're willing to give up at least 1 samosa for 1 beer. You're more likely to give up maybe 2, 3 samosas for 1 beer. Okay. Maybe willing to give up like 2 or 3 samosas for 1 beer. Okay? And what really determines that is the shape of the indifference curve at point A. So if we were to take a tangent line and grab the slope, this is a regularly recurring theme, the slope of a tangent line, but this is going to be, so this purple line is the slope of the indifference curve at point A. That gives the ratio of marginal utilities. Okay, aka it gives you where you're at here versus where you're at here. Okay, so marginal utility for samosas divided by your marginal utility for beer. Okay, how do I know that? The indifference curve is your utility at every point, or sorry, it's your it's a fixed utility for every consumption bundle, right? Samosas on the y-axis, beers on the x-axis. So it's going to be the utility change. Each point is going to be equal utility. So it's basically saying like, what's the consumption bundle like going from here to here that makes me equally well off, and what's the consumption bundle going from like point A to here, or this point to this point, and this point to this point. So at every like minuscule point, you're giving the trade-off between samosas and beer that make you equally well off. Okay, and for you to be equally well off, you need to be giving up some marginal utility from samosas, some marginal utility from beer. And it's samosas on the y-axis, so the slope is going to be the y-axis good, right? So the slope of the indifference curve at point A is going to be the rate of marginal utility for samosas versus the y-axis good versus the rate of marginal utility for the x-axis good of beers. Okay? AKA, how many samosas do I have to give up in order to get the same amount of utility? How many samosas do I have to give up in exchange for 1 beer in order to get the same amount of utility? So let me just draw a line so that you know that I'm pointing to here. So the purple line here is the slope of the indifference curve. It's the marginal utility of samosas, the y-axis good, versus the marginal utility of beers. Every point on the red line gives you an equal utility for samosas and beer. So like some combination of samosas and beer. So going from like this point to the next incremental point, right, you're going to trade some amount of samosas for some amount of beers. Okay. So let's say this is point, I don't want to call it point B because I want this one to be point B. So I'll call this one point C. So there's going to be some really incremental change going from A to C where the marginal utilities are going to have to equalize, right? In the sense of the total utility change is going to have to be the same. Because you're on a fixed level of utility by virtue of being on the same indifference curve. Okay, so like the incremental change from A to C, if you were to plot the slope, would be the rate of marginal utilities. Okay, so I kind of explained that twice, but it's probably not sinking in, and that's fine. It's kind of esoteric math. It's a little bit complex. The way to think about it is your marginal utility, your indifference curve has one level of utility across the whole curve. To move from any point to the utility, you have to basically, move any point along the indifference curve, you have to trade some utility for samosas for some utility of beers, and you're basically want to consume at a point where the marginal utility from samosas that you're giving up is going to be equal to the marginal utility from beers that you're gaining. Okay. And in order to be on the same indifference curve, sorry, I said that twice. The marginal utility from samosas you're giving up is going to be equal to the marginal utility for beers that you're gaining. So if you're at an extreme point on the indifference curve, like over here, right, you have to give up a lot of samosas to get the same marginal utility as you would for one beer. So you're willing to sacrifice a lot of samosas for one beer. So you have this extreme slope over here. Whereas if you're on point B, you're willing to give up less samosas. It should be, sorry, I screwed that up a little bit. It should touch only one point. So the slope should be like this. Sorry, I'm a terrible drawer. Your slope at this point is going to look like this. Okay. And that's like the infinitesimal change, the very small change needed to go from like B to a smaller, like a very close point to like B plus 0.0001 beers minus 0.002 samosas or something like that. Okay. But this is, at this point here, this is the rate of beers or rate of samosas you're willing to give up for one beer. And it's going to be a lot flatter because you're consuming kind of a moderate amount of beers and a moderate amount of samosas. Okay. And at this point here, let's call this point D, which I guess I haven't defined, but this will be an extreme amount of beers and very few samosas, right? The amount of samosas you give up for one beer is going to be very, very, very low because the marginal utility from that extra beer is going to be very low, but the marginal utility from a samosa is going to be very high. So you're not willing to give up one samosa for one beer. You're probably going to give up one samosa for like 0.025 beers or something like that, a very low amount of beers. Okay. Alternatively said, you're willing to give up 0.00025 beers in order to get one samosa. And you're willing to give up like 8 beers in order to get, oh wait, sorry, I got that backwards. You're willing to give up 0.00025 samosas in order to get one beer. So the amount of samosas you give up is going to be very low. The amount of beers you're willing to give up is very high. And you might say, like, I'm also willing to give up one samosa, but I'd have to get like 50 beers in return, or whatever that math works out to, like 40 beers or something like that. Because you're consuming an extreme amount of beers that are giving you very little marginal utility, but you're consuming very few samosas that each individual samosa is giving you a high marginal utility, so you're going to be closer to like this point on the utility function. Okay. So we call this relationship here between the ratio of marginal utilities, we call that the marginal rate of substitution. Okay. Ratio of marginal utilities is called marginal rate of substitution. So I want this to be a little bit bigger so that it kind of stands out relative to the rest of the notes. Okay, and that's also equal to the slope of the indifference curve at point A. Okay, so the marginal rate of substitution in words is how many samosas am I willing to give up for one beer? That's all. How many of good 2 am I willing to give up for good 1? Okay. How many of the y-axis good am I willing to give up for the x-axis good? That is your marginal rate of substitution. Okay, and the overarching theme is you want your marginal rate of substitution to be given by the marginal utility from samosas divided by the marginal utility for beer. Okay, so this marginal rate of substitution is the rate at which a consumer is willing to trade one good for another. It's given by the slope of the indifference curve at each point, or the, I said it backwards, the rate of the ratio of the x-axis good over the y-axis good. Okay. So here I have a little slope in this black line. Here I have a little slope of this black line. Here I have a little slope of this black line. So the marginal rate of substitution is going to be very high here. High, medium, right? Because this has a high slope. This has a medium slope. This has a low slope. Okay. So basically, I switched the axes. Samosas is now on the x-axis, beer is now on the y. But basically, at this point, I'm very willing to give up a samosa. I'm willing to give up many samosas in order to get one beer because I'm already consuming a lot of samosas. At this point, I'm willing to give up a lot of beer in order to get one samosa because I'm already consuming a lot of beer. So the extra samosa is going to have a high marginal utility. The extra beer will not, or the beer that I'm trading off will not have a high utility. And at this point, I'm willing to give up maybe closer to one beer for one samosa. Okay. And you can tell by the shape of the slope. If the slope is steep, I'm willing to give up a lot of beer here. If the slope is flat, I'm willing to give up a lot of samosas. If the slope is closer to 1, I'm willing to trade one beer for one samosa.